Good morning, students. Today we're going to be doing section 3.3. This is intervals of increase, decrease. They're going to be problems just like you did back in Honors Algebra 2. And just like in section 3.1, we will be doing these without a graphing calculator. So if I take a look at a graph of a polynomial function, back in the day what you did was you looked for maximums and minimums. You found their corresponding x values, and then you wrote them as intervals of increase. And then intervals of decrease. And to review, those were x-axis intervals. We'll be doing the same thing today, except that we'll be using calculus to determine those intervals. You can see from this drawing that the intervals of increase, decrease are separated at critical numbers in this case. And critical numbers, to review, are where f prime of x is equal to 0, or as illustrated in this drawing, critical number would be where f prime of x is undefined. So just like we did in section 3.1, we're going to begin these problems by finding critical numbers. So let's take, for instance, the problem f of x is equal to x plus 3 over x squared. And by finding the critical numbers of this function, we will first derive it. So my f prime of x, using the quotient rule, will be low d high minus high d low over the square of the denominator. And we'll clean this up. So my f prime of x will be equal to, we've got x squared minus 2x squared minus 6x over x to the fourth, which will give me negative x squared minus 6x over x to the fourth. And then factoring, I'll take an x out of the top. Cancel those x's. So if you recall, where critical numbers exist is where the first derivative is equal to 0 or undefined. To find out where it's equal to 0, I will use the numerator, and that will give me x is equal to negative 6. And now to find out where it's undefined, I use the denominator. That's at x equals 0. So these two numbers here are my critical numbers. Now what you'll do is, let's make some room here. I'll take my critical numbers and I will use my first derivative to determine where this original function is either increasing or decreasing. And if you recall, the first derivative is in fact a slope machine. So what I'm going to do is I'll create a number line. I'm going to put my critical numbers on it. And what I want to do is I want to test in between into the first derivative. So for instance, you can pick any number within those intervals. I'm going to pick over here negative 10. From negative 6 to 0, I'll pick negative 1. And then from 0 to infinity, I'll pick 17,536. Plugging them into my first derivative. If I take f prime of negative 10 And all you're concerned with here is the sign of your derivative, whether that's positive or negative. The actual numeric value does not matter. So I take a negative 10, plug it into the first derivative. It gives me a positive in the top, and it gives me a negative in the bottom. So from negative infinity to negative 6, this will be an interval of decrease. I'll then do the same for negative 1. I've got f prime then of negative 1. Take negative 1 and plug it in there. That's going to give me a negative on top, and it's going to give me a negative on the bottom. So from negative 6 to 0 will be an interval of increase because I have a positive first derivative there. I'll then use 17,536, plug it into my first derivative. And I'm going to get a negative on top, and I will get a positive on the bottom, which means that I will have an interval of decrease again, going from 0 to infinity. Your final answer then will be to sum this up in interval notation. You've got an interval of increase going from negative 6 to 0, and intervals of decrease going from negative infinity to negative 6, and again from 0 to infinity. And you'll notice that the intervals are non-inclusive of the endpoints. I think that stands to reason. Since the critical numbers are where the first derivative is equal to 0, it is neither increasing nor is it decreasing. Critical numbers will give you potential changes in increase, decrease, but the only way to determine it is to put it on a number line and test. For instance, you could have a function that looks something like this, where you have the first derivative being undefined at one spot. That is, in fact, a change from increase to decrease. However, when you look at the critical number here, which is where the first derivative is equal to 0, you do not get a change from increase to decrease. And again, the only way to determine that is to put it on a number line and test into the first derivative. The first derivative will confirm whether it's increasing or decreasing. Now, I would like to point out that even though this function does not change rather, from increase to decrease here at C, I would like you to break that interval. So in this case, let's call this A. I would say that I have an interval of increase going from A to C, and again from C to infinity. All right, that should be enough to get you through today. I will see you guys tomorrow. Thank you.